Hello students, today we are going to do the next topic of chapter 6, which is very interesting. They are Venn diagrams. As you know, a picture says 1,000 words. So when we do sets using Venn diagrams, it's really become very interesting, and the very difficult question seems to be easier. So what are Venn diagrams? Now we are going to learn all of the things that we have learned in the theory, how to represent them pictorially, right? So first of all, we will learn how to denote sets. In the last video, we had learned about universal set. So when we are going to do practical problems, the very first concept comes with the universal set. This is the set which denotes all the things or all the people or all the elements we are concerned at that particular moment. So you are going to use these Venn diagrams in solving practical life problems. Like if you have performed a survey of a city in 2,000 people, right? You are asking about what newspaper do they read. You have given three options, A, B, and C. Or let's say we start with two only, A and B, right? So you have given two options and you have surveyed 2,000 people asking for their choice, whether they want to read newspaper A or newspaper B. So when you start with 2,000 people, so population of a city is quite large, but you have taken only 2,000 people. So those 2,000 people basically make your universal set, because now we have confined ourselves to those 2,000 people only for the time being. So that makes those 2,000 people as a universal set. It is represented by a rectangle in the Venn diagrams, right? So it is like, if I make a rectangle, we write it as U. Now this, for the particular condition, we can write here as 2,000 people. Universal set contains those 2,000 people whom we have surveyed for a particular thing. Here we have given them a choice of two newspapers, A and B. So this is called universal set. Now, if we have choice, we have to choose either of these two newspapers, right? How can we make these two as the sets? Universal set is the biggest set. Now, if we have to represent A and B here, we can do it this way. One circle may be smaller, one may be bigger, that doesn't matter. And we can do it this way also, right? That we will learn in the next thing. So these are called, let this be A, let this be B. These are called disjoint sets. Disjoint, right? Disjoint means they have nothing in common. Nothing in common. Like if we, like in this particular condition, if we ask few people about A or B, you must have seen practically that there are few families who take newspaper, both the newspapers A and B, more than one newspaper. So there might be some families which are reading both the newspaper. So that will be in this kind. They have something in common. This is the common portion. That means these are the families. Here we represent those families which read newspaper A as well as newspaper B. Right? So we are going to do it in detail. Right now, just focus on this thing, that universal set is a set of elements which we are concerned at this particular moment, right? Now, next is the complement of a set. Complement of a set. If we are talking about only one set, this is the universal set U. Right? I'm writing it with elements also. 1, 2, 3 up to 10. Now, if A is a set which is like 2, 4, 6, 8, 10, then we can make A here and we can write 2, 4, 6, 8, and 10. U is from 1 to 10, right? So now see, this is U. U means up from 1 to 10, all the elements are inside this rectangle. But A only contains these 5 elements inside it. What does that mean? Like 3, 1 to 10. 3, 1, 3, 5, 7, and 9. This is a set of even numbers. All the odd numbers are there in universal set, but they are not inside A, right? So that means A complement is the set of elements which are in universal set, but not in A. So those are 1, 3, 5, 7, 9. Right? This is the complement. The elements which are present in the universal set, but not in A. Right? Okay. The next thing is union of two sets. Union of two sets. How do we define union? U is the same. Like A, I am taking as, here I have to change the example. 1, 2, 4, 5, 7. And B is another set, which is 2, 3, 6, 8. Now, how do we represent it? See, this is A. You can see we have something in common here. How many elements are there? Only 2 is common, right? So 1, 2, 4, 5, 7, 8 are there. So you write it this way. Write those elements this way so that 2 is this common element which is written in the common region. Now 1, 4, 5, 7. 1, 4, 5, 7. Now make a check. This is the complete circle A. You must have 1, 2, 4, 5, 7 inside the circle A. 1, 2, 4, 5, 7. All of them are inside A, but precisely mark this 2 in the region which is common to A and B. Right? Because 2 is a common element for both the sets. Now this is B. 2 has already been written here. We have 3, 6, 8. 3, 6, 8. Now check this B circle. 2, 3, 6, 8 are there. And 1, 2, 4, 5, 7 are A. Now see, how do we write A union B? We had studied A union B is the set of elements which belong either to A or to B or to both, right? So we can start writing elements from here. 1, 2, 3, 4, 5, 6, 7, 8. A union B. 1, 2, 3, 4, 5, 6, 7, 8. So we have covered all the elements here. Since 2 was present in both the sets, I have written it once only. That was the case, right? So this set A union B represents the union of these two sets. Mathematically, if we talk about union, it is basically the addition of two sets. And when we have to mark it, on the Venn diagram, this is the portion that represents A union B, right? A union B. This is the whole part, right? You should know how to mark it on a Venn diagram. Now the next thing is, what is A intersection B? Intersection of two sets on the Venn diagram, right? So I'm again taking U as 1, 2, 3 up to 10. A as 1, 2, 4, 6, 8, and B, right? 3, 5, 6, 8, right? Now see, what are the elements which are common to both the sets? 6, 8, right? So how do we make it on a Venn diagram? Mark the elements of A here so that 6 and 8 come into the region which is common. 6 and 8. This is 1, 2, 4. 6 and 8 are already there. 3 and 5. Right? So what is intersection of two sets? We had learned in the operations. Intersection of A and B is the region or the set of elements which are common to both the sets. So when you write elements, it is 6 and 8. If you have to mark the region on the Venn diagram, it is this portion, right? This is the portion which is A intersection B. A intersection B, right? Next we have difference of two sets. Difference of two sets, right? I'm taking the same example here. This is U from 1 to 10. Now A, we have marked 1, 2, 4, 6, 8. 3 and 5 are there, right? A and B. So what is A minus B? A minus B. A minus B is a set of elements which are in A but not in B. What does that mean? Elements which are in A but not B. That means you have to leave out those elements which are shared by B or which are common to B. So when I mark it, see. I had told you it's only A, right? The portion which is exclusively for A, not shared by B. So you can see what are the elements here. When we exclude the elements which are shared by B, those are 1, 2, and 4. Right? Now, similarly, if we talk about B minus A, A, B. This is 1, 2, 4, 6, 8, 3, and 5. Now, you have to make it other way. B minus A means the elements, set of elements which contains B leaving out A. B leaving out A. That means leave out those elements which are shared by B, shared by A. So what is that? If we represent it on the diagram, this is the portion which is contained exclusively by B. It is not shared by A, right? So leave out this intersection portion and take the rest of the part of B. That means B minus A is only 3, 5, right? So these are the operations on the set. And if you have liked this, watching this video, please do contact me through Urban Pro and share your feedback also there. Thank you so much.